Welcome to our mathematics lesson, and today we are going to look at dividing fractions. But first, let us review what we did in our previous lesson. We were looking at decimals, and when we looked at the decimals, we realized that decimals can be multiplied. Just remember, as we defined decimals earlier on, just like fractions, that it is what forms part of a whole. And when we talk about part of a whole means one, which means a decimal and a fraction simply is less than one. So when we were working on multiplying decimals, we said we simply treat a decimal in a natural way, the way we would treat a whole number. However, we take note of the number of decimals that existed. For example, having a number like 0.2 multiplied by 1.2, these are all decimals. But we said that if we want to multiply decimals, we first assume and treat them as whole numbers. So this one will be treated as 2 multiplied by 12. So it's a whole number. But how many decimal places are there in our first question? This is 1, this is 2. So we have a total of 2 decimal places. So when you multiply this, 2 times 12, you'll get 24. But then, this is a whole number, but we were multiplying the decimals. How many decimals are they supposed to be there? 2 decimal places. So this one forces us to count 1, 2, and you'll find that's where we end. So we find that when you multiply 0.2 times 1.2, you'll get 0.24. Also, we looked at multiplying decimals with multiples of 10. In such particular case now here, we find that it was important for us to identify the number of zeros that exist in a multiple of 10. For example, if we have 6.21 multiplied by 100, 100 is a multiple of 10. So we assume the zeros first, and then we just multiply as usual. We are going to assume the decimal. We already know there are 2 decimal places we are having in mind. We assume the zeros, that is the 2 zeros. So what we shall multiply here is 621 multiplied by 1. And when you do that, you'll find that you get 621. Bring in the number of decimals. There were 2, so we come 1, 2, so it's 621. When you multiply, but when you now bring in the 2 zeros that you left out, we shall move to the right 2 times, so we get the answer as 621. 621. So that is about when we are multiplying decimals. But today, I want us to look at fractions. Now, in our daily lives, we always find that it is very common for us to do the divisions of fractions. We have always done it before. It will always be done. And when we are dividing the numbers, it is necessary that we get to know what exactly are we dividing. Now, this time we are going to look at division, but of fractions, and not the whole numbers or the decimals. So for fractions, I want us to take, for example, if we have 2 strips, these are 2 strips. Assuming that these 2 strips, it was first of all 1. Then we divided them by 2. So that when you divide by 2, you find your 1/2 is the first strip, 2/2 is the second strip. Now, the question here is, we want to take 1/2 divided by 1/4. 1/2 divided by 1/4, which implies that for every strip, 1/2 of a strip that we first took earlier, we are going to divide it by 1/4. So every half 4 other times. So you'll find that our strip will be divided like this. But then the question now comes, what is supposed to be our answer? So let us take one of the halves. So we find that this was, the whole of this was one of the halves, the whole of this was another half. But then we want to divide it by 4, or simply we want to divide it further by a quarter, which means that one single half will go again more 4 times. So what you'll find if you look at this particular case, just to demonstrate, you'll find that we shall have a half of this strip. That is, we shall have 2 of the halves being chosen. Now what has happened here? We find that when we are dividing a half by a quarter, we have got only 2 units of the whole half strips that we had. So how do we simply apply this? Then it means that a half divided by a quarter is equals to 2. A half divided by a quarter is equals to 2. So this situation is what we are now going to consider. How come, or how did we arrive at 2? By the end of this lesson, you will be able to handle fractions and divide them without any problem. There are so many situations where this division of fractions exists. For example, if you can have lollies, let us take a packet of lollies with 24 lollies. If we have a packet containing 24 lollies, and then from the 24 lollies, we say that we would wish to divide the 24 lollies to a group of 3. So if we are to divide by 3, alternatively we would say that we want to give each group a third of the lollies that we have, which is 24. You'll notice that by dividing by 3, or by getting a third of 24, the answer remains the same, which is 8. So what are we saying here? It is that the division and the fraction here have got certain relation, which we are now going to consider as we work out the sums. So what are we supposed to know when dividing fractions before we look at the exercise? Now, the first thing we need to know when dividing fractions, we must be able to find the reciprocal. Reciprocal. Now, when we talk about the reciprocal here, what do we mean? When we talk about the reciprocal here, we are looking at the number that you have been given, or the fraction that you have been given, you invert it. Or you simply swap the denominator with the numerator. You invert it, or simply swap the denominator and the numerator. For example, if we want to find the reciprocal of 1 over 2, then the reciprocal is 2 over 1. We have swapped the numerator and the denominator. Simple. At the same time, if you don't want to swap, we just say we invert. Because at times you will be asked, what is the reciprocal of a whole number? So if you want to find a reciprocal of a number like 3, then we shall introduce a fraction by making 3 over 1 so that its reciprocal will be 1 over 3. Again, by introducing the denominator of 1, we find that we are able to swap the denominator and the numerator. So that is the very first thing we need to do. For us to be able to divide fractions, we first must be able to find the reciprocal. And in general term, we can simply say that the reciprocal of A over B is equals to B over A. That is the general rule about reciprocal. Also, we need to have a few other considerations when dividing fractions. This is dividing by a number is the same as multiplying by its reciprocal. So we are saying that dividing by a number is the same as multiplying by its reciprocal. Let us look at an example here. Take, for example, 15 divided by 3. 15 divided by 3. This is a whole number dividing by a number. Following this rule, then we shall say that this is the same as taking 15 multiplied by the reciprocal of 3. Therefore, the reciprocal of 3 will mean that we introduce a denominator of 1 so that we find that the reciprocal of 3 becomes 1 over 3. So in our question, we reduce our question to be 15 multiplied by a third. And we can simplify, cross-simplifying, cross-cancelling here by 3, 1, by 3, 5. We find the answer is 5 multiplied by 1, which gives us 5. So we've been able to demonstrate that when you are dividing by a number, is the same as multiplying by its reciprocal. You can also use a calculator to confirm your answer by simply taking 15 divided by 3 using a calculator, and you'll find that you'll get the same answer. The third step that we need to observe is when asked to divide by a fraction, instead choose to simply apply the fraction's reciprocal. Now, when we are asked to simply divide by a fraction, when we are dividing by a fraction, then here, instead, choose to multiply by the fraction's reciprocal. Choose to multiply by the fraction's reciprocal. What are we trying to say in this particular case? As we have seen earlier on, we said generally if we have a fraction like a over b, you are given a number divided by a over b, it's simply simple, multiply by its reciprocal, and the reciprocal here reciprocal here is simply b over a. So we are saying, given any number, and that number is in fraction form, and you are supposed to divide by that, you simply take and multiply by the reciprocal of that particular fraction. And lastly, when dividing mixed numbers, when we are dividing mixed numbers or mixed numerals, they must be changed into improper fractions. They must be changed into improper fractions. So these are the rules we are going to observe as we go through. Remember, when you talk about improper fraction, these are situations where the numerator is larger than the denominator. And when you talk about mixed numbers or mixed numerals, this is where we have whole numbers and fractions together. For example, a number like 2 and 1 over 3, this one is simply a mixed numeral. And you can change it into improper by multiplying the denominator and the whole number, that is 2 by 3, which gives us 6 plus 1 gives us 7 over 3. So this one here is mixed numeral, and this one is improper. So when dividing mixed numbers, we must always be able to convert a mixed numeral into improper fraction. So let us go to specific questions to confirm the points that we have listed above. So in our question, we have state the reciprocal of the following: 2 over 3, 5, and a mixed numeral of 1 and 3 over 7. In our solution, now we first find that from the first general observation of reciprocal, we said if we have a number like 2 over 3, it is a fraction. And we said to get a reciprocal, you simply invert the denominator and the numerator, which means if we have a number like this, then the reciprocal, this implies that the reciprocal of 2 over 3 is, when you invert this, which will be 3 over 2. It will be 3 over 2. Now here, note that what we have simply done in this particular case, what we have only done, we have simply swapped the denominator and the numerator. We have simply swapped the denominator and the numerator. So it means that for a fraction that is straightforward, you don't need to struggle to find its reciprocal. You only need to swap the numerator and the denominator, and there you are. So our reciprocal of 2 over 3 is 3 over 2. Let us look at the second one. A number like, we have 5. When you have 5, to get reciprocal of 5, as we said earlier on, we shall need to introduce a denominator. So reciprocal of 5, we shall introduce a denominator whereby it's the same as saying 5 over 1. Then we swap the denominator and the numerator, and we find it will be 1 over 5. It will be 1 over 5. Now, here, we should be able to think of 5 or look at 5 as the same as 5 over 1. That's what we have. And then we swap the numerator and the denominator. For the last one, which is the mixed numeral, we have 1 and 3 over 7. You'll notice here that these are mixed numeral. When you say you want to find or to invert, we cannot get what are we going to invert or what are we going to swap. The denominator is there, fine, the whole number is there, but it's not one simple fraction. So we need to change this. So the first thing here, we change into improper fraction. And when you change this, it is 7 times 1, which is 7, plus 3 gives us 10. So we have 10 over 7. So here we have a fraction. Now we can find the reciprocal of 10 over 7. Therefore, reciprocal of 10 over 7, it will mean that we swap the denominator and the numerator, and you'll find that when you do that, you'll get 7 over 10. So that is what you get when you are finding the reciprocal of a mixed numeral. Remember, we first changed it into improper fraction. Then using the knowledge of A over B, we swap the denominator and the numerator to get our reciprocal. Let us now look at dividing a fraction by a whole number. And the question says, find a So we have two questions here. The questions here say we want to be able to divide a fraction by a whole number, and it's asking us to first find the 5 over 8 divided by 3, and also find 2 and 3 over 11 divided by 5. Let us start with the first one. We have 5 over 8 divided by 3. You remember the first thing here was that anytime we are dividing by a whole number, we need to introduce a denominator for the whole number, so that now we change this and be the same as multiplying by its reciprocal. So this one is the same as 5 over 8 divided by 3 over 1. So we have introduced, you'll notice we've introduced the denominator of 1. Now the next thing that now follows, this one, we shall simply invert. So it will become 5 over 8 multiplied by the reciprocal of this, which is 1 over 3. In case we have places where we can simplify and cancel, we go ahead and do it. But if we do not have, we multiply using the rule of multiplication of fractions, where the numerator multiplied by each other, you get 5 times 1, which is 5, and the denominator multiplied by the other denominator, which gives us 24. So this one is telling us that when you divide 5 over 8 divided by 3, what you get is simply 5 over 24. Now let us look at the second one. This time now around, we are not only handling a fraction, but we have brought in a mixed numeral, so that we test the knowledge of changing a mixed numeral into improper, which we had done earlier on. So I expect you to apply the knowledge of changing a mixed numeral into an improper fraction. So the question is 2 and 3 over 11 divided by 5. As we can see this is a mixed numeral, and the rule says we must first find the improper fraction of the mixed numeral that we have. So we shall expect to change mixed numeral into improper fraction. So that is the first approach you are giving. So 11 times 2 is 22, plus 3 gives us 25. So this one is 25 over 11 divided by 5. Again, the second part is a whole number, so we introduce the 1 as our denominator so that we shall be able to find the reciprocal. So we shall introduce here a 1. When we introduce there now a 1, for this we shall simply invert, or we swap the numerator and the denominator, which implies that this question will be now 25 over 11 multiplied by 1 over 5. As we saw earlier on, we can simply cancel maybe horizontally, or not horizontally, but diagonally and vertically. For this particular case, we have got a diagonal cancelling. So by 5 here is 1, by 5 here is 5. So 5 times 1 gives us 5 over 11 times 1, which gives us 11. So you'll find that your answer here, when you divide this mixed numeral by 5, you should be able to get 5 over 11. So in that case, we have been able to apply various signs. Note that anytime you change the whole number to be a fraction and get its reciprocal, the sign changes from being division to multiplication. That is what we should be able to observe every time we are approaching fractions and we are dividing fractions by whole numbers. So we have seen about dividing a fraction by a whole number. Now let us look at dividing a whole number by a fraction. Find 6 divided by 1 over 3 and 24 divided by 3 over 4. So for our first question here, as we saw earlier on, it's a whole number. So take the whole number that you have, we are dividing by a fraction. So that one is straightforward. When you divide a number by a fraction, it simply is the same as multiplying by its reciprocal, or multiplying that fraction when it is inverted. So this one will be 6 times the reciprocal of a third, which is 3 over 1, which gives us 18 over 1, which equals to 18. So you'll notice here that instead of us maintaining a third here, we have found the reciprocal and we have multiplied by 3. And the sign has changed from division to multiplication as long as we are dividing. For the second question, we have 24 divided by 3 over 4. Just like other questions we have approached, we are dividing by a fraction. When we divide by a fraction, it is the same as multiplying by its reciprocal or its fraction inverted. So in this case, we shall have 24 multiplied by the reciprocal of 3 over 4, which is 4 over 3. Now here we shall notice that there is a possibility of cross multiplication, cross cancelling, where we have diagonal cancelling, that is by 3 here 1, by 3 here is 8. This one gives us 32. So in this particular case, we've been able to simply find that 24 divided by 3 over 4 is the same as 24 multiplied by 4 over 3, which gives us 32. And remember to keep your answer as simple as possible. And that's why in this particular case, we have to cancel. This is just to simplify and leave your answer in its simplest form. Where we have the denominator as 1, because if you can notice, this will give us 8 times 4 over 1 times 1. So the case here is 32 over 1. So any number raised to 1 is simply the number. That's why we have 32. That's how we handle when we are dividing whole numbers by fractions. Now let us look at a third case. And this particular one now, we are going to divide fractions and other fractions. So we're going to look at dividing fractions by fractions. Dividing fractions by fractions. So here we have two fractions. Find 3 over 5 divided by 5 over 8. The two of them are both fractions. Then we saw earlier on that when we are dividing fractions, we should be able to remember that when dividing fractions, it is the same as multiplying by its reciprocal. Where the reciprocal in this particular case, you have swapped the numerator and the denominator. So here, this will be the same as 3 over 5. When we place the sign multiply, we shall not maintain 3 over 8, but the reciprocal of 3 over 8, which is 8 over 3. And when you have 8 over 3 here, then you'll find that we are able to cancel here by 3 here 1, by 3 here 1. You'll find you remain with 8 over 5. In fractions, it is always advisable that you keep your answer in its simplest form. So 8 over 5 is improper fraction. So we need to simplify it further, and we shall now find a way and write it as simply a mixed numeral. So 5 goes into 8 ones, remainder 3, and so we maintain 3 over 5. So that should be our answer when we are dividing this sum of two, when we are dividing this question of two fractions. Next question, we are going to take mixed numeral divide by another mixed numeral. So in this particular case, we have 2 and 2 over 5 divided by 1 and 3 over 5. So those are, you'll realize that both the two are mixed numerals. And the rule of dividing fractions, we cannot work out a fraction when it is in its mixed numeral. So we first of all, we shall need to convert both of them. We convert both the two into improper. So this one, instead of saying 2 and 2 over 5, we shall say 2 times 2, which is 10 plus 2 is 12. So this one will be 12 over 5. So instead of having 2 and 2 over 5, we shall write 12 over 5. Divide by, the other one will give us 5 times 1 is 5 plus 3 gives us 8, so we shall have 8 over 3, 8 over 5. Now here we are now ready to move on and start our multiplication or division and so on. We are dividing two fractions, so when you divide into fractions, it's the same as multiplying by its reciprocal. So it will be 12 over 5 multiply by the reciprocal, which is 5 over 8. Look at where possible can we cancel. 5 is common here, so by 5, 1. By 5, here 1. 8 and 12 has got a highest common factor of 4. So by 4 is 2, by 4 is 3. So we have reduced this one to 3 multiplied by 1 over 1 multiplied by 2. That's where we are. So 3 times 1, you get 3, and 1 times 2, you get 2. When you simplify that further, you'll get a mixed numeral of 1 and 1 over 2. 1 and 1 over 2. So we have been able to simply look at fractions and divide by other fractions. Now, we've seen that in fractions we can have figures and numbers, and we deal with them directly. But sometimes these fractions can also be applied in some areas. Like we have a question, a whole statement, it's upon you to now find out how are you going to extract fractions and apply from the statement. So let us look at the next question. Now, looking at this question, if 2 1/4 leftover pizzas are to be shared between 3 friends, what fraction of pizza will each friend get? What fraction of pizza will each friend get? Now, you notice that this is a statement. It's a whole sentence. But they're asking us to simply calculate the fraction each one is going to get. You'll also notice that we are not talking about only one pizza, but instead we are looking at simply the leftover pizzas, which was 2 1/4. That's the leftover pizzas that's supposed to be shared among 3 friends. So if we are to reduce this into fraction in our solution, you'll notice that we shall have to first find out how much of the total pizzas do we have. And the total pizzas that we have is 2 and 1/4. And the total number of friends that we have, the friends we have are 3. So we want to divide this one by 3. So this is the quantity of pizzas left over, and this is the number of friends that are supposed to share this pizza. So you'll notice this one now takes us back to the fraction that we know. We have the first part here, which is in fixed, is an improper, is simply a mixed numeral. And we are dividing by a whole number. As we saw earlier on, as we saw earlier on, we shall find that this one cannot be worked on unless we convert this into improper. So what I've circled here is improper, is mixed numeral. We need to convert this into improper. So to convert into improper fraction, we shall need to take 2 times 4, which gives us 8 plus 1. So this 2 1/4 is the same as 9/4 divided by 3. We are dividing by a whole number, so we introduce the denominator of 1 so that we are able to find the reciprocal of 3. Given that we have 3/1, we can invert the numerator and the denominator and find that what we shall get here is now 9/4 multiplied by the reciprocal of 3, which is 1/3. So when you cancel diagonally by 3 is 1, by 3 is 3. So we are remaining with 3 times 1, which is 3/4 times 1, which is 4. So let us get back to the question and see what they were asking for. The question was, what fraction of pizza will each friend get? We are finding that each friend will get 3/4 or 3/4 of the leftover pizzas amount. That is 3/4 of the leftover pizza that they had. So in this question, Miriam cuts 10 millimeter sisal rope into 4 equal pieces. If the rope is 3 and 3/5 meters long before it is cut, how long is each piece? So we first need to ask ourselves, the issue of 10 millimeter rope, that is the size. It's not going to make a big difference. It's the size of the rope. But the length of the rope before it's cut. And then we see that rope, when we cut it into 4 equal pieces, what does each piece represent? So the total length of the rope is 3 and 3/5 meters long. This rope has been divided equally into 4 parts. Equally into 4 parts. So now to translate the sentence into mathematics here, we shall find that this is the same as saying 3 and 3/5 divided by 4. Already now we have reduced this into fractions. We are dividing fraction by a whole number. This is a mixed numeral. We cannot, so we need to convert it into improper. So 3 and 3 over 5 into improper is the same as simply 18 over 5. That is 3 times 5, 15 plus 3 gives us 18 over 5. Divide by 4. When you are dividing by a whole number, it's the same as multiplying by a reciprocal. So in this case here, we introduce a denominator 1, so that instead of having 18 over 5 divided by 4 over 1, we simply say it is 18 over 5 multiplied by 1 over 4. A quarter is the reciprocal of 4. The highest common divisor in this 2 or factor is simply 2. So by 2 here is 2. By 2 gives us 9. There is no any other common factor. So 9 times 1, we have 9 times 1 over 5 times 2. This one gives us 9 over 10. Now, this is not just a fraction. We were asked from the question, remember, we are supposed to find how long is each piece. So, what are we trying to say here? If the whole 4 parts, one part is simply 9 over 10. 9 over 10 of what? It is 9 over 10 of the total. We are looking at it, 9 over 10 of the total length of the rope, which is 3 and 3 over 5 meters. So our answer should be in meters and not just left in this particular case. So when you take these meters, divide by this number, you should be able to get this of a meter. So we are saying that if you take 3 and 3 over 5 meters long rope, divide by 4 equal pieces, then you'll find that you'll get each piece represented by 9 over 10 of a meter. So that is it for today. In our next class, we are going to look at dividing decimals. Thank you.